Okay, everybody, this is Math Man here with my helper, and we're going to take a look at a problem that I found posted on YouTube by Presh Tall Walker or something like that. Anyway, it had to do with a problem where we had two discs, and the two discs were such that one was 1/3 the radius of the other. So the one that's numbered 1 has a radius of 3 inches, and the little disc here labeled 2 is 1 inch radius, and at least as close as I could get them to be. It's thick cardboard, and I am having a hard time with the music going on. But anyway, the problem was given when you turn this disc around the bigger disc. How many revolutions does the smaller disc undergo to complete a full circuit around the bigger disc? And so I did a little math, quick math, and I looked at the bigger disc, which I have here labeled as 1, and the smaller disc labeled as 2, and I took the ratio of the circumference, because the smaller disc has to travel as it rolls around the outside of the bigger disc. It's traveling around the circumference of the bigger circle. So the circumference is given by the formula C equals 2 pi r. And so the circumference of the smaller disc is 1/3 that of the bigger disc. So when you take the ratio of the two discs, you're going to have the bigger ratio, or the bigger disc to the smaller disc is going to be a ratio of 3, because the bigger disc is 3 times the size of the smaller disc, at least in its radius. So then I imagined, what if I unrolled this larger disc so that it was flat, and I took its entire circumference and made it flat so that the smaller disc rolled along the bigger disc. Now, the problem was stated such that as the smaller disc progresses around the larger disc, how many revolutions does the smaller disc undergo to make a complete circuit around the larger circle? And the answer, I claim, was 3, because the distance that the smaller disc has to traverse is 3 times the circumference of the smaller disc. In other words, the smaller disc has to make 3 complete turns in order to traverse the distance of the circumference of the larger disc. And the individual who put the video on the YouTube site, Presh Tall Walker, indicated that it was 4. And the reason he said it was 4 was this, that when you look at the smaller disc, let's start at this starting point. I've got the smaller disc lined up with the bigger disc at the same point, and then as I roll around this bigger disc, the smaller disc seems to line up at the 3 o'clock. At the 3 o'clock point. See, the word hello there is the same as here from my perspective. So hello will show up there. Now, they considered that it had to undergo a full revolution in order for me to be able to read the word hello. But the problem with that is the little disc hasn't made a complete turn until it rolls all the way around so that that point touches the circle again, which is at 120 degrees from the main line of the initial starting point. And in fact, it touches the circle only in 3 places. That's when the smaller disc makes a complete revolution about its axis. When it's at the 3 o'clock position on the disc, it hasn't made a full 360 degree turn. It has only revolved 270 degrees. So a full revolution is not until that disc touches the disc like that. Now the smaller disc has made a full 360 degree turn, and in fact the smaller disc can only make 3 such turns as it proceeds around the circle. So it becomes a matter of defining the problem and the perspective of the problem. Is it from the vantage point of the viewer who is outside of the system of circles, or is it from the vantage point of the smaller disc itself? Now, if the perspective is from the smaller disc about its axis A, then the smaller disc has not made a complete revolution until the line touches the surface again, and that's the same as a tire moving along on a straight road hasn't made a full revolution until that point has contacted the road surface again. And I have that depicted here, imagining that the circumference of the larger circle was unraveled and laid flat, and that the smaller circle was rolling along the surface of that flattened distance, C, or C1 that I've labeled it here. And it actually takes 3 complete turns to traverse that distance. So the answer, technically, the correct answer is that the small disc is made 3 revolutions about its axis A. You see, my perspective outside of the system, above the system, when I'm looking at it from above, is not the same reference point. And so from here to here, it looks like it's made a full revolution, and it has, from my perspective. So you see, the problem with this particular problem, this geometric problem, is that the curvature of this circle comes into play as the smaller disk revolves around the surface of the larger disk, giving it the appearance that it's made a full revolution. And it has, but only when you define the reference point, and the reference point being your eyes, your vantage point. Now, without defining it that way, you can't say that the smaller disk has made 3 revolutions, because in essence, when you're talking about the small disk's axis itself, it's only made 3 revolutions as it proceeds around the circle. So that is an ambiguous problem, and the trouble with that problem is that it needs clarification. It needs definition in order to be able to provide an answer, or a correct answer. So you see, these are the types of caveats that need to be considered when you are looking at a mathematics problem, because often an individual may not define exactly what it is he means or is talking about when he's verbally explaining or expressing a problem. So that is my commentary on this particular problem. I think it all depends on how an individual defines the reference point. Now, with that said, I just want to add a note that it was difficult for me to get these disks to be exactly 3, a factor of 3 off. In fact, the bigger disk had a a real radius of 2.99 inches, whereas the smaller disk had 1.05. Now, those may seem like small differences, but when you look at the ratio of C2 to C1, that ratio was almost 0.2 inches different for the entire circle. And when you look at the difference between the circumference of the circle at 2.99 and 3 times the circumference of the smaller radius, then you have a difference, delta C, or the magnitude of the difference of the delta circumference. It was 0.335 inches. And that's significant because these lines then, when you roll that disc, these lines are not going to line up like that. These lines are going to be something like that, And so it really makes a difference. You have to be pretty precise when you cut these things out. So that is an observation. Again, I was very, very close to being a third of a radius with the smaller disc, but not exactly. And it was enough to be a little bit disconcerting when I rolled it around, and when I realized that I had made an error in actually creating the radii for both of those circles or discs, it made a significant difference in the. That's where precision comes in engineering and in science. A small tolerance when things require precise engineering, you have to be very, very concerned or careful about how you go about actually fabricating something. In this case, the fabrication had no consequence. But when you're talking about a spacecraft, 0.335-inch difference could be huge. In fact, when the space telescope, the Hubble telescope, was put into orbit, it really wasn't much of there were spacing washers that were used that affected the focal point of the Hubble reflector telescope and made it so that all of the images were fuzzy. And they had to send a special mission up with the space shuttle to correct the difference, the blurred images. So when you're talking about precision, it's important, especially when you're engineering something. When you're looking at something like this, where we're just showing the theory, it isn't as critical. So anyway, that is my take on this problem. And for me, when someone speaks of a revolution, how many revolutions does the small disk undergo as it traverses its way around the bigger circle? My answer would be 3. And in fact, when the test was given on the SAT, the correct answer was indeed 3. So there wasn't, 4 was not an option in the multiple choice answers for that particular test. The expectation was for the answer to be 3. So it again is a matter of where you're defining your reference point to be. And if you're talking about the disk and the reference point being the smaller disk's actual axis of rotation, then you're talking about only 3 full revolutions. So with that, this is Mathman wishing you all well.